Hello everyone, I am Sachin pursuing my Masters in Robotics and Autonomous Systems. I am working with Professor Bharadwaj, who is the chairman of the Department Robot Bot Center for Cyber Physical Systems. So my project and my research is on control and design of remotely operated water vehicle. It is also an underwater vehicle. We will discuss about it in the coming slides. So introduction. What the project is, we have seen so many robots like aerial robots and ground robots, which are very developed and which are being used in all the aspects in delivery and even ground robots and so many things. But we have not seen that much advancement in underwater robots. So there is a vast requirement and vast necessity of underwater robots, which we will be discussed right now. So there is a in our planet Earth, on our planet Earth, how much growth we are seeing above water. There is a lot more hidden underwater. So to explore all those manually, it is very difficult. So this is where underwater robots will come into picture. So the environment which is underwater, the environment is also very difficult to perform the tasks. For example, if we record something and we want to get that information, the sensors have to withstand the pressure of the depth of 100 meters depth and 150 meters depth. So the environment is also very challenging and difficult. So we are thinking to develop on it. So why solve this problem right now? As I have told you earlier also, there is a vast requirement of underwater robotics. And presently the geopolitical tensions which are going right between so many countries, the fighter jets, the aeroplanes, which are easily visible and easily tracked with the radars. And so if we use underwater some small stealth robots, which are very difficult to capture and which are difficult to see from far distances. In this place, we can use underwater robots. So mainly the Coast Guard and naval Indian Navy has a large demand of underwater robots. So the main objective of my underwater robot is the true objective is to develop a remotely underwater vehicle which will be useful for surveillance between the states borders or some countries borders, which we will be deploying them. And they will give us the information. They will be keeping on giving us information. So there are some private companies also which they wanted to develop this underwater robot for the cleaning of the sewage. Till now, we have seen so many sewages being cleaned by manually. A person enters inside the sewage and removes the clog, and it will come out, and the man will come out. Here we will release the bot. It will unchoke the clog, and it will do the person's work. Methodology we have used here is, um, first we have used a test kit which on based on test kit we have made our own prototype, and we have given the control and motor drivers on it. We have tested it in our own swimming pool with the help of Gymkhana and assistant registrar. And based on that result, we got to know that we have to increase the payload if we have to give that to Navy and Coast Guard, and we have to equip so many sensors to it. So this is the methodology we have used it. Structural design. The structural design I have used is polyvinyl chloride PVC pipes. We may think that PVC is very lightweight, and no, PVC is very strong and it has a very high resistance. And the main advantage is it will not get corrosed underwater or rusted underwater. That is the main advantage, and it is very lightweight also. The controller assembly, we have used the switches as I have told you, this is a remotely operated vehicle. The remote, we have used DP/DT toggle switches, double pole double throw switches. It's a type of switch that has two separate sets of contacts that can be switched between two different positions. So this allows far more complex switching arrangement compared to the SPDT switch. So thing I have told you, as I have informed you, the swimming pool in Gymkhana authorities have helped us a lot to test our swimming pool there. That swimming pool videos will be here. So this is the video, and this is the payload. We have used a 1,250 grams, which was unsuccessful. the bot got submerged underwater, so it was unsuccessful. And we have tested our bot in our sewage water also, which is very unclean water. It was successful there also. So these are the pictures while we were testing underwater. So after testing, we have come to the results that ROV is very successful and with a weight of around 700 to 800 grams. But if it is crossing around 1200 grams, it is getting submerged. So we got to know that we have to increase the thrusters potential. So I am concluding that this is the project which I have done in ISC, and it was a really helpful. We are thinking to make it more helpful for Indian Navy and Coast Guard also by equipping with sensors. And after equipping with sensors, we will take out the data from the bot to the man who is operating it. The future work is, if the ships are going right now, the ships are going like this, we will equip these bots to the ships. So if any enemy is attacking us, these bots will take the damage, and it will warn the ship, and it will keep the ship safe. So this is the future work. So I have used some references. Thank you.